A very good afternoon, everyone. We'll begin our today's session shortly.
Good afternoon, ma'am.
Hello. Hello. Hello.
Hello, sir.
Can you hear me?
Yes, sir.
Okay. Let's do. Hello. হ্যাঁ, সো আমি জাস্ট একটু দেখে নিচ্ছি ক্যামেরা রেট এগুলো আর কি। Hello. Just 1 minute. Let me share the screen. Just hello. Hello.
Yes, sir.
Is it? I shared the screen. Is it visible?
Yes, sir. It is visible.
Is it moving?
Yes, sir. It's moving.
Okay. Fine. So I think
Hello, yes, sir.
Ah, right. So I think 1 or 2 minutes you will be taking, no? Is it?
Sir, hello. Can
Yes,
you hear
yes.
me?
Yes, I hear you. Please.
Sir, please wait for 2 minutes. Actually,
Okay,
uh,
okay, okay, okay.
introduce yourself first. So then we will start the session.
Now, okay, then can I take 2 minutes
Yes, sir.
time? Can I take 2 minutes time? Hello, hello.
Yes, sir. I think you can take. You can take. No
Okay,
problem,
okay,
sir.
okay, okay, okay.
A very good afternoon, everyone.
Good afternoon.
I really welcome you all to our second day of our FDP session. Today, we are having with us, good afternoon, ma'am. So today, we are having our session with us with Professor. Sorry for the interruption. So let's begin with our today's session. Today we are having with us our session with Professor Santi Prasad Mehti. He is a professor in the Department of IT, IIEST Shivpur. Professor Shanti Prasad Mehti is a professor in the Department of IT at Indian Institute of Engineering,
Yes, please.
Science and Technology, IIEST Shivpur. He has been a faculty member since 2000 and has held various leadership roles, including head of multiple academic units such as the Purvi Das School of IT, the School of VLSI Technology, and the School of Mechatronics and Robotics. Professor Mehti Sir has earned his PhD in Computer Science and Technology from IIEST Shivpur in collaboration with the Machine Learning Intelligence Unit of Indian Statistical Institute, Kolkata. He has also completed postdoctoral research at the Laboratoire des Signoc at Système in France. His research interests encompass cognitive radio networks, MCCDMS systems, digital watermarking, compressed sensing, and applications in diabetic retinopathy. Professor Mehti Sir has received several accolades, including Best Paper Awards for conferences at such as CCSN 2015, Micro 2016, and ICAC 2016. He has also been selected for the LEAP 2020 program, a leadership for academicians initiative organized by IIT Kanpur, sponsored by the Ministry of Education, Government of India. With an extensive publication record and a strong commitment to academic leadership, Professor Mehti Sir brings a wealth of experience and insight to his role as a keynote speaker. I really welcome you, sir, for today's session.
Yeah.
I would like to request you, sir, to continue with our today's session. Thank you,
Okay,
sir.
okay, okay. Thank you so much for your nice introduction, ma'am. Good afternoon to all participants.
Thank you, sir.
Yeah, so I think it's better I just off the video, maybe because of I don't know whether it will be any problem. Let me show this. Okay.
Hello. So what do you can now present, sir?
Yeah, I think there was some disconnection. Maybe let me.
Yes, sir. Now it is presented and it is visible, sir.
Is it okay?
Yes, sir. This is visible now.
Is the slide moving?
Yes, 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 sir.
Okay, okay. Sorry for the interruption. Very good afternoon to all. Thank you, ma'am, for your nice introduction. It is indeed my pleasure to be present in this invited talk. Thanks, organizer, for giving me chance to deliver this talk. Possibly this theme of this FDP program is just progress in the next generation AI. So when I was thinking for the topic, I was really in a confusion what to add, because in that sense this talk will not take much on the very lucrative or very attractive AI models or sort of things, but what I just like to think otherwise, the existing or widely used AI, ML, DL based approaches, how can it progress the society? So keeping this in mind, I just made my title of the talk is Next Generation AI and IoT, Synergy in Shaping Future Society. So the outline of this talk is something like that. If we see the last couple of decades, I would say, over the last 3-4 decades, there have been tremendous progress widely in the fields of computer and communication engineering. One is the birth of digital computer, and other one is the mobile wireless communications. So if we see the first part, the birth of digital computer had introduced a machine to the society, which is much more capable of processing numerical data than a human being. So, but much of the information that human being capture from the society process are non-numeric in nature. So a pertinent question arises, is it possible to incorporate human intelligence or human-like intelligence inside a machine-like computer to process non-numeric data like audio, visual, images, the way human does this job in an intelligent manner? And that gives rise to a couple of subjects over the last couple of decades in the form of AI, in the form of image processing, computer vision, and pattern recognition. On the other hand, if we see the wireless mobile communication from 80s onwards, there have been a tremendous progress in the fields. It was the first generation in 80s, then second generation, third generation, fourth, fifth, now people call beyond fifth and sixth generations. And if we see the paradigm shifts or movement from the data communication field or wireless communication fields, the first generation analog voice communication no longer exists today. It much on the data-centric communication. There have been a paradigm shifts in 4G, 5G. People much on voice-centric operations. It also involves the data-centric operations. High data rate transmission, large volume of data to be processed by the human beings. So if we just look back, what makes attractive the 5G? There are a couple of technologies. One is the millimeter wave communications, or what we call it, so that the giga bands or terahertz communication in that sense, one can say. Other is your the massive MIMO, the multiple input, multiple output. Other one is the beam forming, small cell concept like macro cell, pico cell, like that, cell formations. Then other one is the NOMA, non-orthogonal multiple access techniques. And of course, the computer science people where the contribution is mobile edge computing. So we understand that the birth of digital computer and mobile communications leads to voice-centric communication to data-centric operation, huge data. Large number of devices need connection worldwide, so seamless connectivity, and it's basically the service-oriented applications, right? So we see that because of the emergence of the Internet of Things, it is expected that there should be 10 to the power 7 number of devices per kilometers expected to be, and everything wants to be in the frame of Internet of everything. So a big challenge how this wireless node to be seamlessly connected, how they should reliably talk each other, exchange the data. And these IoT devices, if we see its otherwise, I mean, in a very lucid sense of definitions, it comprises of actuators, sensors. It is having unique identifications code. It should have sort of communication protocols where it can connect machine to machine, device to device, and capable of exchanging any service from anywhere. Like that. So these devices should have the intelligence ability. It should have learning ability. It should have decision making ability. It should have sort of semantic analysis ability. So a device to have cognition, to learn, think, decision making, aggregation, analysis, and all this. So it eventually involves the automation. It eventually involves the intelligent operations and optimization in different target operations. So we see that connectivity, computation, sustainability, because these IoT devices are mostly battery limited. They work with limited power. They work with limited storage. They have the limited computing facility. So there are constraints. There are constraints in terms of sustainability, computation, and connectivity. But they need to do the intelligent operations. So they need to do huge amount of data analysis, and that's data analysis go for semantic analysis. So integration of AI, IoT makes a revolutionary change in the future days society. And there are various forms of IoT networks emerges, like say for example, Internet of underground things, Internet of medical things, Internet of industrial things, like that, Internet of vehicles, and huge promises and the potentials. It would be having the impact on agriculture and food. It has the impact on healthcare support. It has the impact on smart cities, smart homes, transport system, intelligent transport systems, gas monitoring systems, environment monitoring systems, weather predictions. It should have impact on, education, human mind, everything. Now, as the title is AI IoT, so I just like to say we have the at hand huge amount of data. We need to reveal the pattern of that data. We need to model the data for their semantic analysis. And this data not only to be processed isolately, it needs exchange from one devices to another devices. So we need to take care of the wireless mobile channel connectivity issues. So IoT and this AI is having an impact on the coming days sustainable society. If we so let's see that this is the which I like to say in the context of 5G or beyond 5G, that different promises and the potentials, and there are different factors which are responsible. But the more important things in the context of AI, IoT, and computer science perspective is the mobile edge computing, which reduces the distance between the cloud server and the end users by bridging the computing facilities closer to the devices. And some of the services to be done in apps, and some of the to be done in the edge computing devices. So this is one contribution for making this 5G more attractive from the perspective of the computing field. So that's why in the next slides, I like to say that it is computational intelligence and IoT that likes to synergy in shaping future society, because this computing is in different field, forms like fog computing, edge computing, and there is network slicing and network virtualizations, data virtualization, control virtualization, network resource sharing and virtualization. So this is basically this pictorial diagram likes to say the essential things which I like to share in the coming 1.5 hour times, like that computation and communication, automation, intelligence and optimization. So challenges are massive connectivity, sustainability in of the devices, latency and storage. So for the sustainable society means it needs to include the rural sector of the country. So it needs remote connectivity of rural area, and of course the impact on healthcare, industry, automation, weather and environment, safety, agriculture and food. So in this talk, I just like to say how AI, the different machine learning, deep learning techniques, especially the CNN, the autoencoder, generative adversarial networks, reinforcement learning and its various variants like DQN, deep reinforcement learning, DDQN, DDPZ, all these to be synergistically used to address the some of the issues of different fields that I show here. So as per the sustainable society is concerned, we have the challenges of physical resources scarcity. If we can see the fuel consumption are getting reduced, and our transportation sections are facing a big challenge. Not only that, it is, I will show sometimes later that a car in a year emits a tons of carbon dioxide and greenhouse gases emissions, which creates a challenge to the environment. So these physical resources in terms of, say, for example, fossil fuels, how these issues can be taken care. Energy is an important issue. The electricity is problem. So how it can be renewable energy to be used for the human purposes and others. If you see our country, the India is a big country, and if you see there are large number of rivers, but at the same time you will find that there are scarcity of waters, and particularly there have been a rapid changes in the environment, and particularly the weather and the monsoon. So the seasonal agriculture depends on the rainfall, which is a very threat, and particularly the scarcity or the security of the water is also very challenging. If you see that some of the countries throughout the year there are water, and some of the rivers throughout the years there are waters, but some of the rivers they are having almost dry major times of the year. So can we look for a kind of connectivity, river connectivity, so that the water can be available in all parts of the country in a very normal way, and it can be made use purposely. And we see that human population go on increasing, so there is a challenge in the food and agriculture. So how it can be made use by using AI, smart aquaculture, biofoundry, so that there have been a tremendous change in the form of environment, like say drought, like your flood. So how we can go for a cultivation that can take care of this stress of the environment. That is a challenge. Smart city, smart home, complex architecture floor plan. You see the building construction, when we share a complex floor plan to the different types of clients. The clients may be the common users, the clients of buildings or others, or it can be builders, it can be engineers, it can be brokers. So so different people have the different way of objective. So how a complex architecture or floor plan can be analyzed by means of AIML, so that before construction, one can predict the building materials and how much the expected cost and all this. So that's a very promising techniques to be used for AI-driven building construction, predictions, modeling and all. Safety, health and environment monitoring in mine tunnels, because you can see the mines, there are different types of hazards. These hazards are not only the environmental hazards, but also the miners who work there. So it needs a constant monitoring and this data extensive analysis such that the safety, health and environment can be monitored, and AI, ML, AI-based techniques to be there. Then disease prediction from the food habit and lifestyle, the human mind prediction. I would say it's the bigger challenge in the coming days because of the societal impacts. Human minds are getting changed, so it needs the entering inside the mind space, and a big analysis of the data, human minds, prediction, behavioral pattern understanding is also the issue, and obviously there should be an impact on role of AI. So in a nutshell, the intelligent, automated and optimized system design is the demands of the day, and there is the need of different forms of AI techniques to use. Now, as I say, with this, I'm not going to talk about any kind of AI or deep learning or machine learning tools, techniques and like that. I just like to say how different some of these AI ML techniques or MLDN techniques to be used in different application areas. So the first I will start with the food and agriculture. You can see that global food demands that 9.7 billion by 2050, agriculture and 1/3 of the greenhouse gases are coming like that. So climate change, as I say, there are, erratic behavior of the climate or environment. There are unpredictable drought, floods, landslides, etc., etc. It creates the human lives a threat, as well as in the, say particularly for our country, agriculture mostly depends on the monsoon dynamics, and there has been a drastic change in the monsoon dynamics, and it's the time to model this monsoon dynamics, accurate modeling and hazards prediction to prevent the human being. I will come to this point later, but the climate change makes a great impact on the food and agriculture. So what we can think of like that, the predictive IDO type. Basically, if we think about a plant and there are couple of omics, like multi-omics. For example, if we can say genomics. Genomics is the blueprint of the plant, the genetic blueprint of the plant. That means what it is capable of. Then transcriptometry, transcriptometry. Say for example, genomics, as I say, it is the blueprint of the plant DNA. So what it can capable of. And transcriptometry mix means it just like to say in the trace situation, which blueprint remain active. So that is that understanding is basically essential. Then proteomics means which proteins are which cells are working on, which cells are working on. Then metabolomics means it just like to say what chemical reaction occurs, what it generates. Is it nutrients? Is it sugars? Is it stress? Sort of things. That's a very important things. So this predictive type IDO type means if we use the machine learning based approaches, and if we multiple layers of omics, as I already say, if we can make use, then we can decide that which one can be, which to be effective during the stress situation, like say flood or in the drought. Now, a RL agent, reinforcement learning agents, can play an important role. Imagine that, say for example, a robot selects seeds from the multiple options. Now, after selecting these seeds, it just tests it in the lab environment or in the field, that whether it can sustain the adverse situations or advanced environment or like that. So after this success or failure study, it can just decide, it can just learn, basically the robot learns that which traits seems to be the very effective. I mean, it is the long root or the thick leaves. Now, once this is learned, so it can make use in the next cycle to select the best particular seed. So what I'm going to say, that if we incorporate the machine learning based approaches to incorporate the different types of genomics to decide the different types of seeds or traits, and then just making use in designing cycles, that this seems to be the very effective. So it can make use. So what it can say is selection of seeds can be thought of like an actions, and based on its outcome in the lab environment or in the field, it can make use of the reward or the the penalty mechanisms, and that way it can improve the the productivity. Second more things can be, this is the first part, where the objective is to crop varieties that perform better under future climatic stress like drought or flood. Then monitoring systems, it is AI-based real-time AGI monitoring system. So for example, we assume that the fields are covered with sensors. So it just having the sensor which can measure the soil moistures of the soil. So it just prevents the wastage of water, or it needs when the watering is essential or not, like that. Or it can make use of, say for example, thermal camera which can measure the crop temperatures, or it can make use of the UVs which takes the pictures so that crop health can be monitored like that. Now, instead of, there are two kinds of approaches, particularly the IoT edge networks can play an important role. Instead of transmitting all this data to the cloud and waiting for longer duration of decision, some of the time critical analysis can be done in the edge devices by using Raspberry Pi or sort of Jensen, the tiny Jetson Nano tiny ML algorithms. One can make a decisions of time critical analysis. So this is one way it has an impact, that each IoT has an important role in agriculture and all. After that, we can go for foundry. That means synthetic sort of things like environment friendly biology. In that sense, carbon efficient synthetic biology. What it is like to say is that here it is again, the RL has an reinforcement learning has an important role. So for example, imagine a microbes, a cell, and it would be convert into form of a factory. It will just consumes the waste carbons or food scraps like that. So these microbes, so RL can plays an important role in some part of the genes to be turned on and off, so that a better kind of microbes to be generated. So, and we can go for a PHA, the bioplastic generation mechanism. So it should be a sort of things like DBTL. DBTL means design, then build, then test, then learn. So what you'd like to make use that a robot will design a systems where it can choose the best microbes and or sort of things, the traits, and then it goes for that way the build that best particular one, then go for the testings, and based on that it will learn so that it can improve or it can goes for the better selection in the next cycle. So all these three operations which I say ML plus RL, this is basically your selections of seeds and traits like that. Then monitoring and management field efficiently by means of edge IoT architectures, and we can also go for producing eco-friendly materials from waste, auto ML, and RL plus synthetic biology. So this way it can having a role in the fields of your food and biofoundry. Now I will go for another use of the AI/ML techniques or deep learning techniques for the crisis solving or for solving the food problem, the smart aquaculture. In the next part, I will be talking about the smart aquaculture. Smart aquaculture is a kind of cultivations in the water where these cultivations to be for organic materials like fish, like shellfish, algae, etc. And for its efficient, smart aquacultures, one has to the most important things that needs attention is the water quality. Monitoring of the water quality, so water quality monitoring and water quality predictions are very essential. Now imagine that for continuous monitoring of water quality and prediction has an impact on the smart aquaculture. It can reduce the labor, enhance the production, at the same time optimize and reduces the resource uses, improve the sustainability and profitability, and of course it has the impact on the environment, because you can see this organic organisms when cultivations are going on, it has an impact on the society or in the environment. So one has to go for its continuous monitoring, and it can be done by means of using deployment of these sensors, which can be used for monitoring the water quality and predicting the water quality. Now these sensors are very costly. Imagine for a small farmer or a poor farmer for which it is not possible for continuous monitoring or deployment of the costly sensors and others. So what it can be used like that, see, we can go for a surrogate sensing or virtual sensing. That means the actual sensors are not being deployed. The low-cost sensors are deployed. Say, for example, the temperature of the waters are measured by using the low-cost sensor, and that information is transmitted to the by means of your edge IoT networks, and using AI-based approaches or deep learning-based approaches and making use of the chemical equations, chemistry equation, we can find that dissolved oxygen. So dissolved oxygen, salinity, pH of the water can be estimated by using deep learning or AI-based approaches by making use of the low-cost sensor of the deployment. So as I say here, the dissolved oxygen can be measured from the temperature sensors data, which are very low cost, and AIML has an important role. So in some of the works where it is talking about this research, these people they have contributed and they have made use of the CNN for features and LSTM based approaches for sequential data monitoring and by LSTM approaches. So CNN and by LSTM techniques are used for improving the accuracy of the water quality monitoring parameters, and that way it is virtual sensing, so it makes use of the very cost efficient solutions. So this is one way one can make use of the deep learning and machine learning approaches in the smart agriculture. Now I'll be coming to the second part where I'll be talking about the healthcare, and I like to focus much on this on different types of issues, different types of, particularly the different types of cancers and different types of deep learning techniques, starting from the skin cancer detection by using histopathological strain images and by using simple convolution and neural network. Then I address some of these retinopathy problems and data scarcity problem by means of generative adversarial network, deconvolution based generative adversarial networks. Then we'll be talking about the bagging based ML algorithms for oral cancer detection, deep reinforcement learning based oral cancer detection, simple CNN based architectures for pneumonia detection. And finally, I will be going for typical type of imaging microscopy, low cost, because the rural health support IOMT framework and SDN IoT framework for healthcare support. So in this part, what I will be talking about, the first part is the malignant melanoma detection in H&E, hematotoxin and strain images. Basically, it is for, if we see the digital histopathological images are very large in size. So a pixel is very, very large, and it is very difficult to annotate, or very difficult to human annotation. So any kind of digital diagnosis has an impact, is an important role in this. So automated segmentation of malignant melanoma regions in HE and STAY images, hematotoxin and eosin images. So it's very, very important. We make use of the CNN this is one of our work where we have make use of the CNN based techniques, and we have the three types of classifications. One is the melanoma nucleus, non-melanoma nucleus, and background region. What essentially does that CNN is used for extracting the or segmentation of the melanoma nucleus. Then This melanoma nucleus is used as a structural element, and some morphological operations like erosion and dilation is used to grow the melanoma region. So there are two things. The first part is say CNN-based nucleus segmentations, and basically this is done by a kind of improved NSNet architectures. I'll be in the next slide. I'm talking about this one. So basically, there are different techniques in images. Generally, people when go for image analysis, there are two types of features are important. One is the coarse features, other one is the details features. Generally, the signal processing people make use of different signal processing techniques like frequency domain, Fourier transform, or wavelet based approaches or like that. When we go for deep learning based approaches, it is an improved architecture of NSNet architecture, which has been two parts. Instead of NSNet architecture, where are 5 layers, there are actually 25 layers, and this is split into two parts, A and B. I don't know whether you can visualize properly or not, but just I tell, nothing is there. The A part is basically responsible for coarse representation of the image and the background, whereas the B part is responsible for finding the fine details of the image as well as the background. How it is possible? Because if you can see here, it is the convolution, batch normalization, then rectifier, ReLU like architecture, and P is corresponding to the pooling operation. If you see the A architecture, so it is basically C, that is convolution, that is the feature extraction, batch normalization, ReLU, nonlinear activation function, and pooling operation that reduces the size. And this latter part is just basically the reverse thing. Instead of pooling, it is unpooling. So if you see the structure A, it is basically the first part is the pooling operation, and the second part is the unpooling operation, and bilinear interpolations are used to enhance this size. So it is giving one way the features. Whereas in the second part, if you see, here you can find that there are different filter size: 3 cos 3, 5 cos 5, 7 cos 7, 9 cos 9, 11 cos 11. So it's a multi-resolution analysis to get more and more finer details. So it gives rise to the finer details of the features, and these features are concatenated. Then it is passing through a softmax layer, and it gives to the classification. As I already say, the pixel classification here are 3 class. One is the nuclear, melanoma nuclear, non-melanoma nuclear, and background. Once this melanoma nucleus is segmented, detected, then it is followed the morphological operations like dilation and erosion operation. Dilation operation enhances the size of the object. So to overcome that, to nullify that effect, the erosion operation is done, and that's basically shows, as I say, that accuracy of the order of the 85% accuracy of the segmentations. And so this is very early part of this work. And next I will be talking about the generative adversarial architecture, particularly the CS image reconstruction. This is another signal processing approaches connected with the machine learning, or the deep learning approaches like generative adversarial network. What it has been done, you definitely face a challenge in deep learning or machine learning works, the scarcity of the data. So two essential problems in DL or ML is the data scarcity and is the data imbalance. The scarcity of the data, to overcome, generally people use the data augmentation, do some kind of affine transformation and others like that way. Now what we are doing here, generative adversarial networks, but these generative adversarial networks not in the original space. We are making use of the compressive sensing. Compressive sensing means you are sampling images, subsampling. So image quality is poor, and that means you have a low resolution images. How you can reach to the high resolution images? It's purposely serve the two jobs. One is the low resolution to high resolution, and other one is the data augmentation. To understand CS in a very brief way, you can think of that you have a linear equations where the number of linear equation is less than the number of unknown variables. So it is mathematically underdetermined problem. Go back to your school day mathematics. You have a 2x plus 3y is equal to 10. somebody gives you this equation and asks you to find the values of x and y. What we generally do, take a value of a particular variable, and with that value we calculate the different value of the others. So we have an infinite solutions. Out of that, which one seems to be the best solution? So compressive sensing is basically an inverse problem. You have an endpoint data, but actually data is the endpoint, which is n very greater than n. So what I'm going to say is that you are capturing image or data which is of endpoint, but actually your image is of endpoint, n is much greater than n. So our challenge is how we can go from an endpoint image or data to endpoint. That is the CS reconstruction problem. And here we make use of the deconvolution generative adversarial network. As you know, a generative adversarial network comprises of two units. One is the generator, other one is the discriminator. Generator is basically trained with the noise data, and discriminator is the real data. Generator update itself to make whether the generated data is real or to make a real data, and discriminator decided whether this data generated by generator is real or fake. So here what we have done, we are going for the different CS measurement space by changing the measurement space. That I mean by changing the value of n, we are creating different reconstructed image of size n. So that way we are creating the good resolution images, as well as we are solving the data augmentation problem. So whatever data is available, we are going for its first representation in compressive sensing framework. By changing the measurement space in the reconstruction network, we are creating more data with different resolutions. So that way we are creating data augmentation. Now once this phase, so I'm not going to this, as you know, that is a very challenging, and generator and discriminator training one after another it goes on, and with the objective function, it binary cross entropy is used. I'm not going to talk about in details about this one. So this generative model, generative adversarial network model, does the two operations. One is the low resolution image to high resolution image generation, and it takes care of the data augmentation. Now, how this can be used in remote healthcare support? Imagine that the villagers are there, suppose generally for pneumonia detection, particularly the radiologist prefer to the use of the chest images, X-ray chest images like that. Now you imagine that this data, the patients are in the remote area, and this chest images needs to transfer to the city or suburban where the radiologists or the experts are there. So diagnosis to be done in one hand, and capturing or imaging is done in another hand, and it needs a transportation problem of the image. So we just make use of a techniques of CNN, how CNN can provide the diagnosis in two parts. One is the CS measurements are done. So if we see this block schematic, this is the chest image. We are making use of the compressive sensing measurements. So the image size is very reduced. This image reduced size data is essential for storage and transmission purposes, because our original data when compressed, so it would be useful for transmission, energy efficient transmission, and also reduces the delay. Now what we are doing here in CNN, we are just making use of the two flanks. One is the responsible in the CS feature space. Here is the here is the classification. So it's basically the CS data, and this classifier determine whether it is pneumonia or not. And at the same time, we are having another CNN architecture that's responsible for reconstruction of the images. Because a few minutes back, you have seen that we have a structure which is DC or deconvolution generator, which can make use of this. So we have make use of this one, a kind of autoencoder architecture you can think of here, that encoding followed by decoding. So this architecture is making use of here. We are reconstructing the images in the, and the doctor, after seeing this one, make a diagnosis. So we have now two solutions. One solution is the machine solution, other one is the human solution, and that can make use of the structures effective, and how the CNN architecture is used for that. What I'd like to say other way, that by changing the size of the data, how we are getting the accuracy value of the diagnosis. This is the proposed method, and obviously you can see, as because of the publication always looks for that your algorithm seems to show the better results compared to the other. So that we also having the improved result compared to the existing methods. But what interesting things is that even if we are transmitting 20% of the data, that means a 100-point original data, even if represent 20, and by following CS reconstruction and classification, and this is we are having this kind of accuracy in the classification. Okay, then we go for oral cancer detection. Generally, for cancer-like detection, you can see the papillomacular, smear test, pap smear test, which is very gold standard. This is very, very gold standard for cancer, pap smear test. But the challenge is what? It is complex training process. You need to go for a training process. And second important thing is it's subjective. Different radiologists will diagnose it in different ways. So to overcome this problem, we also go for the multimodal. That means we have the PAP images and we have the Fourier transform infrared spectroscopy. What it gives some property of molecular signature, which is not visible in the PAP images. But when we go for Fourier domain infrared spectrometer with bright field imaging, we can have that molecular signatures. Now, making use of that, we are now using kind of bagging algorithms. We are using multiple classifier like SVM, random forest, and multi-layer perceptron. And we have the three classes: cancerous, precancerous, and normal cells. We are making use of those, and we are having 89% sensitivity and 86% specificity, offering a clinically robust automated level 3 oral and cancer detection. This was published, in one of the conference, very prestigious conference, the medical fields in USA in the April. So when we see the numerical values, we find that the spatial domain approaches, the PAP-based approaches, when show the accuracy of different machine learning algorithms this much and spectral this much, the bagging algorithms improve this 92.3%. And this is the result. So that's for oral cancer. Once this is one algorithm for oral cancers. When we further go for the oral cancer using deep reinforcement learning algorithms, what we have done over here, we are using a reinforcement learning. I think you know the reinforcement learning is a kind of approaches where an agent explore in an unknown environment by means of heuristic approaches, trial and approaches, and it gathers knowledge about the unknown environment. It takes some actions. Based on the outcome of these actions, this is rewarded or penalty. So it has an objective to maximize the cumulative rewards. So basically, this is the deep learning based approaches. It works on the concept of the way we learn. We gain experience from our mistakes. So reinforcement learning in such a kind of techniques, in one way you can think of, it improves its by taking some actions, and that actions may be rewarded or maybe penalty invoked based on the outcome returned by the environment. So deep reinforcement learning algorithm for segmentation and feature fusion for oral cancer prediction. What we have done here is that we are using deep RL. Generally, deep RL means the reinforcement learning plus deep learning. Generally, deep learning or CNN helps in the extractions of the features and classifications and all. Particularly out of the many, one has to take a decision. So that decision is done by reinforcement learning approaches. So DRL, when clubbing together deep learning and reinforcement learning, so the features, classification, and decision making, the best one is coming by means of the combining of DRL. Now, CNN, this segmented image. So DRL is used for segmented image. From that segmented image using CNN, we are getting the features. And now the original image is also run with CNN having the features. So what we have done basically, instead of using many tools, we are using CNN deep reinforcement. We are using initial seeds. Now these seeds are geometrically transformed to cover the your tumor regions. So essentially, we start with different types of seeds of rectangular block, and that blocks are translation, flipping, rotation like that. We extended and merged together, split merge like techniques to to cover the the tumor regions. So this way the tumor regions is segmented. Now this segmented tumor regions followed by CNN algorithms, the features are extracted. Another is the original image, the CNN features are extracted. So feature concatenations are there, fusions are there. Now this we are using the approaches of the classifications, and we are getting the results of 97% cancer classification accuracy by multimodal feature extraction. So this is the two approaches, as I say, segmentation CNN features and original CNN features, feature concatenation, dense pair classification, and performance goes to the 97% accuracy, which it was earlier our backing base image classifier, both PAP images and the Fourier domain data together was 91 point something like that, 92.3, which now is 97%. Now we'll be talking about another which is very cervical cancer. Cervical cancer is another which you can see that this is the fourth severe as per the WHO statistics, and in India relates to mention the severity of this one. Basically in the rural sector because of the lack of healthcare, conscious education and all. So what we have going over here is the low cost microscopic development. Basically, as I already said, that PAP images, PAP is the gold standard, but it is the complex training process and subjective interpretations are the difficult things. Another imaging techniques is what? The THC. C corresponds to what? Contrast. And DIC means differential interference contrast. So this phase contrast and differential interference contrast, these are techniques that is used for imaging purposes, but they have the problem of contrast problem. They are very costly and there is a halo effect, a pseudo depth like information are here. So this is again problem. To overcome this one, autofluorescence imaging. What is autofluorescence? Autofluorescence is a property of an object. The object absorbs light in one wave and it emits in another way. So this autofluorescence imaging is another level 3 imaging which is having the benefits in sense that intracellular metaboloids, it gives a kind of change in morphological operations. So this change, it appears in inception or during progression of the cancers. So this intracellular metaboloids, this to be used, which makes a morphological change during inception and the progress of the cancer. So we are going for an autofluorescence imaging scheme. Actually, I'm not having the much time of talking about here. Basically, you can think of a circle where different colors of LEDs are there. So this is rotated, and by this way, we are generating the multicolor, multi-band images. But here we are talking about only the RGB color of images. So we are talking about a framework of Internet of Medical Technology, where we are having the SDN, software defined network IoT light architectures. In the next slides I'll be talking about. So basically what is here, it is the SDN controller which is having equipped with main deep learning algorithms, and this is the cloud. So the patient's low cost imaging, microscopic imaging, AF imaging data or images are dumped to the cloud. The SDN controller access this data and generates the algorithms. Now for providing this to the users connected with the mobile apps, what it is basically there, the SDN, the edge network. So there are module 1, module 2, module 3 like that, which is some module trains with the predefined parameter. So this controller run the ML which is having the predefined particular parameter. So the train networks downloaded to here, and it's a tiny approach. It operates very faster and makes the time critical decisions. So this is the basic operation which we have submitted, and we get a review from the IEEE Journal of Internet of Things. Hopefully we will address this one. So this is an approaches. Generally, the here also, even if we are having a low cost imaging modality, but still there may be a problem of data scarcity. Now you can make use of this generated data, whatever available microscopic low cost images. You can make use of the data augmentation like say autoencoder based approaches, or you can go for your generative, I mean GAN model, which I write here. So basically the extensive image processing operation is done in SDN controller. What it is done, it is decomposed into red, green and blue channels. Then it is decomposed by wavelet transform, low frequency and high frequency. So these are merged together, fused images, and basically after that data augmentation by means of variable autoencoder or generative autoencoder we have done, and then make use of race rate 50 and VGGNet, and we are calculating the, go for the classifier, which is very funny algorithms, and you need to go for how, even one can think of host convolution like YOLO 5 architectures for reducing the computation, or even you can go for a deep learning based approaches where it can provide you the particular configuration, particular layers, particular number of nodes, particular connections. So this can reduce the computational complexity at the edge. One architecture which I'm going to show here is basically the work of IIT Kharagpur's research group, the SoftHealth, software-defined fog architecture for IoT application in healthcare. What they have done, they have making use of the time criticality analysis of the, basically the physiological measurements are very time sensitive. And you know that when it is a IoT or it is a, much of this part is basically the reliable connections to the server and all. And this reliable connection is a communication issue. I am coming in our research group, we are taking care of that one in the other next one. But here you can see this wireless network connection people are not addressing in the physical layer perspective, assuming that they are having that a good wireless connectivity. Now this delay, packet loss, network overhead is very, very important. So time criticality analysis is very, very important. So when patient data is coming in the edge servers or edge nodes, it is decided that whether the data is time critical or not. If it is time critical data, it's decision to be done here and to be communicated to the patients. If it is not like that, then it to be extensive computational tasks or learning based approaches, so it should go for the cloud. So controller decide progress, processing to be done at fog or in the cloud. ML or DL algorithms present in controller unit and cloud storage source. Train sub modules as I already said, predefined parameter. These are so we have proposes a software-defined network in conjunction with IoT for addressing this healthcare support problem. Now, as I say, in this work, we like to say how this reliable connection of wireless communication. And again, we are making use of the reinforcement learning approaches. So two issues for reliable connection. One is the channel availability, whether the channel is free or not, because the free channel for healthcare or dedicated channel is not there. Because and communication, the channels are very costly. It is already used, particularly the low frequencies are heavily crowded because of the different communication services. But the good things is these channels are not always used, dedicatedly used. So there is a vacuum or spectrum of holes. So one can go for opportunistic transmission or like that. That's called cognitive radio network. I'm not going to that. What we are going to hear that we are predicting by means of reinforcement learning, we are predicting whether a dedicated or a licensed channel spectrum is free or not. And based on that, we are going for a RL based approach. Why it is very, very important, particularly in wireless medical telemetry services, particularly in hospitals, there are very costly, sophisticated instruments are there. And that instrument needs protection from electromagnetic radiation because MRI image devices and others. If you are having a wireless communication and get affected, electromagnetic compatibility or electromagnetic interference, so malfunctioning will be there. So it needs a low power electromagnetic, all communication to be done at the low power level only. So this needs protection all like that. So that is why we go, in our work, what we have done, we go for a spectrum prediction by means of reinforcement learning. We make use of a penalty and reward like approaches. If the free hole is correctly detected, so the device will transmit medical data. If it is not, I mean, if there is data collision, so it has to make use of the penalty in terms of data transmission of the license user, cooperating in the latest license user. So that is basically the kind of approach where by reinforcement learning based spectrum prediction, when we plug, we are going for a complicated designs, sophisticated designs. The design is what we need to protect the radio sensitive devices from the electromagnetic interference, and these devices should have own energy for its sustainability, because the devices, particularly, all our laptops, mobile phones, these are battery driven, and we need to go for a frequent recharging. Particularly if you go for a sensor network deployment, and these devices needs replacement of battery, or you need to go for a recharging online. So what we can think of, that can we go for an energy harvesting? So these energy harvesting schemes are considered, and it is expected that whatever power is required for device to data transmission, for medical data transmission, that power will come from the the harvested energy. So this is basically a constraint optimization problem, and we make use of the RL based approaches, and we design it for particularly the IoT healthcare support in the hospitals. Now I will be going to the third application. Application is the weather and environment monitoring. Needless to mention, the continuous rainfalls over this part and other part, and you can see the Uttarakhand, there have been, so it's really a concern for the globally, that weather monitoring and its predictions. If I just give in the metro areas, Mumbai flood, there were 300 millimeter 6 hours, Delhi heat waves, then Surajpur drought, Central India agri district. So these are all having, particularly if you can think of country like India, where the much of the cultivations depends on the seasonal rainfall, and thus such erratic behavior of the monsoon is very, very challenging. Not only that, particularly as I for example, the human hazards. So the prediction of the hazard. Two things are very, very important. One is the monsoon dynamic prediction, and other one is the prediction of the hazards. Now understand the problems. I'm not going to details in that, but there is the research component. Understanding of the monsoon dynamics. What we can generally, the existing methods, you deploy the sensor, collect the data, go for analysis. Now again, it is not a costly, because cost effective. It is costlier approaches. So we need to go for a digital twin. We have to go for much on the sensor deployment cost to the lab. So we need to find the modeling. So modeling means, we generally say that there is urbanization, there is the cutting of trees, and all this has an impact on the environment and like that. So of course these are factors, these are directly. So there are some hidden patterns, some latent informations which we are not having direct or indirect way of implementation, has a significant impact. So we need to go for understanding, accurate modeling, understanding the latent features which has an impact on the environment. Once this is understood, we can go for the specific sensor deployment, which can be very cost effective. And if we can predict accurately in ahead of time, so we can have the scope of saving human lives. If you can 45 minutes alert, we can 50 million people in risk zone, we can take the same. So what one can think of, that cost-effective early warning via virtual sensing and digital twins. Then we can go for a kind of, say, for example, landslides, for example, flood, or for example, the droughts or whatever. So for example, zones like Himalaya and others. So we may not have the enough data, and we can make use of the generative AI. We can go for a diffusion-based approaches for thousands image creation for minutes or for seconds sort of things, so that we can make use of the real-time analysis on that. Hybrid AI hydrodynamics model that can reduce it the 40%. So targeted edge computing, as I say, that's in the context of like, so two things are very important. One is the monsoon dynamics modeling, and second one is the prediction of these hazards, which can save the human life, which can save the resources and the foods and others, agricultures and all this, human life. Now coming to the other operations, other application was the gas sensing network. It's a very, very important things. The chemical industry or the environment. The environment, the air quality monitoring is a very, very important thing. Against this urbanization, against this industrialization, cutting of the trees is a gross impact of the environment. So there are many volatile organic compounds in the air, like say ethanol, methanol, isopropanol, and all these. And we are having different industrial, chemical industry. It needs the protection of the workers working there. So continuous monitoring of the gas in real time by using low cost sensor deployment. By saying low cost, it enters the consumer electronics fields. So you need to choose the electronics devices in such a way which have less impact on the human environment. For example, the material would be renewable, materials would be reusable, materials should consume less energy. In one sense, the low-cost sensor deployment is very, very challenging, because when you deploy low-cost simple fabrications, because of the gross deployment, there is again the intelligence operation need to incorporate, and this intelligent operation consumes energy. So it's a multidisciplinary research field, starting from material science, starting from IoT, starting from AI, ML based solutions, as well as it is the so multidisciplinary in the sense signal processing, sensor, materials, AI, IoT, and edge computing, and all this to be taken into consideration. So this is one approaches what they have done. They people use a ferric oxide based semiconductor, metal oxide semiconductor, low cost. As I say, the sensor low cost when, but its performance to be high. So deployment of high performance yet low cost. Now when there is a sensor low cost, this faces two challenges. One is the sensitivity, other one is the selectivity. Selectivity means cross selectivity, in the sense multiple gases and the particular one to be accurately sensed or accurately detected. So this becomes a challenging. And what they have used, the low cost ferric oxide based, lithium ferric oxide based metal semiconductor, MOSFET, they are used for sensor and make use of the machine learning algorithms for enhancing the sensitivity. So this is their works, they make use of this one. In a recent one of our work, which are in under review in IEEE Consumer Electronics magazine, there was a call of special issue, and it was the consumer electronics, and it should be intelligence in consumer electronics devices along with the 5G and wireless connectivity. What we have done over here, this kind of concept, but they have not taken care the concept of machine learning based approaches of use of this. And they have, machine learning they have used for detection or enhancing sensitivity, but they have not taken care of the assurance of the wireless connectivity. So what we have done here, we are considering a SDN IOC, Internet of Consumer Electronics. We make use of a reconfigurable intelligence. We imagine that a chemical industry, inside this indoor, there are attenuation, radio signal or sense data need to not be reliably transmitted. So what we are looking for, how the communication to be ensured, wireless communication to be ensured. So we are solution proposing that's consumer electronics, sensors, then software defined network, reconfigurable intelligence surfaces, which improves the multiple copies of the transmitted signal, radio frequency energy harvesting. So gas sensors devices sustain from its own by harvesting energy of the radio frequency or renewable energy. So this is an algorithm what we have shown here, that existing communications are going on Wi-Fi or WiMAX communication, sensors are deployed, these sensors are harvesting energy from these ongoing RF signals, then it just senses the data. This data is transmitted through a reconfigurable intelligence surface so that data can reliably reach to the edge devices. And again, this concept is basically your SDN network. Here it is the extensive machine learning algorithms are done in the cloud server. HDN controllers is running that by accessing this cloud data. Then cache devices, it is just make use of this rule policy. That means how to operate in the sensing. The gas intensity goes like that. How to operate the instrument or equipments monitoring like that. So this rule policy is stored in the cache server, and this way it is operating. So this communication problem, to ensure our wireless communication, we say that outage to be minimized and these devices to be self-sustainable, and both the communication should satisfy the data rate. So that's why this is maintained like that. Well, I'm not going to the details of this, but here is algorithms where we use, it's a complex constraint optimization and reinforcement learning we are making use for here in the form of two deep queue networks. One deep queue network is responsible for monitoring these communication purposes, reliable communication, and another deep queue network is responsible for gas sensor networks, its monitoring and the decision making process. So this is basically, I'm not again going to the details of this part. All you know that those who are, having the reinforcement learning, you know that it's, the cumulative reward maximization, and it basically operates on the Bellman equation. This is that Bellman equation. So it takes the best action so that it should have the cumulative reward should be maximized. So I skip this part, and this is some of the results which say that continuous gas sensor monitoring by means of using two deep queue networks is essentially providing the effective solution for reliable sensing data transmission as well as the monitoring of the different types of. As the more number of gases increases, the energy consumption go on increases. And compared with that, we are getting, because of the good results, because we are considering the reliable connectivity of the edge devices, clouds, server, HDL controller, and other devices. So this is one work. Now I will be going to the intelligent transport system, because as I say, the root cause is again for gas monitoring, weather monitoring, and transport system is again some impact on the environment in the form of your fossil fuel depletion, and the fossil fuel cars emitting, as I say, 4.6 tons of carbon dioxide is emitting per year. And so this is basically your environmental protection agency, they reports like that way. On the other hand, who reports that particulate material should be of the order of this one, but generally the report says it is of the order of this one. So we have to make a shift in the transportation field. We have to go for electric vehicle systems. If we, you can say that electric vehicle is not, very new. It is already in operation, and somewhere you can see. But again, this challenge in the electric vehicle is the battery. You need to frequently, within a period, you need to go for a recharging. So before completion of the travels deployment, battery drainage, you need to go for recharging and other. So you need for an optimal routing policy so that it can ensure it's based on the state of the charge. So initial work, it was basically when people are going for electric vehicle transportation, the deployment of the charging infrastructure, because charging infrastructure is a very costly affair. So charging infrastructure deployment and routing policy, you can see that early there are rich in literature, the Dijkstra's Bellman-4 algorithm, like the way people use the shortest path, and all these are extensively used in the early part of this work. But currently, it has been extensively used, the reinforcement learning, deep reinforcement learning, particularly the DQN architecture and others like that. So we are talking about some of our work. So the challenges is basically the diverse anxiety, because he needs to complete the journey before the full depletion of the battery. So it needs having a kind of routing policy or plan such that before complete drainage of the battery, it can go to the charging station and recharge, and at the same time complete the journey within the specified time. Now in the latter part of the research, there are the time critical issue of the transportation coming into the pictures. Incident like say accident, fires, congestion, these are coming into the situation. But the early work they didn't consider like that. I'm talking about one of our work which has been accepted in this year in intelligent transport system, where we are making use of generative adversary. Starting from the beginning of the problem, let's say we are thinking for a smart city development, and we are looking for a road network development. We are considering a mesh type of network. We network represent in the form of a graph, and we are using a generative adversarial network, spatial graph generative adversarial network concept to generate road network. And so basically our that's we are making use of two things in the AI-based approaches. One is the road network generation by means of using spatial graph generative adversarial network. So we represent a kind of vertex and edge, adjacent symmetrics and edge, and we are making a decision. Discriminator has to make a decision whether it is a belongs to the true road network, the vertex is there or not. So this is one, and then reinforcement learning we are using for optimal route planning, where our objective is the travel to be completed by minimum energy consumption and within a specified time. So there are integration of SGGAN for road network development, and once the road network is development, based on the charging station deployment, multiple vehicles needs to plan out the routing techniques such that the energy consumption from arbitrary source to destination to be minimum for travel completion, and it should be within a specified time. We are making use of bipartite gap because once the optimal paths are developed for the particular vehicles, it needs the association that the vehicles to be associated with a particular charging station. Otherwise, it may be a particular charging station would be heavily flooded with the vehicles on the way of optimal paths, and other will be less utilized. So we make use of the bipartite based associations of the electric vehicle and charging station. So this is one of our work, and when it is compared with the existing literature, it shows a kind of benefits of energy reduction 2 by 6.8, and we are making use how good our generated road network to the real network, along with the different, we are using the Kullback-Leibler divergence to measure the similarity. So this is one work. In the IIT Kharagpur people, see again in the intelligent transport system, there is the time criticality issue because some of the transport vehicles are very time critical. For example, ambulance is very time critical. For example, other intelligent transport, say VIP people or like that. So you need to go for a time criticality analysis of the the traffic. So so what they have used there, they have make use of the augmented reality and virtual reality. So it is basically the roadside unit, the camera, it takes the photographs of the road conditions. This goes to the edge nodes, and edge node decided about the road conditions. These road conditions are transmitted to the clouds as well as these SDN controllers and cassette devices. So SDN controller makes the policy or the routing policy for the vehicles, which is updated to the SDA switch, and this SDA switch then propagate this policy to the vehicles for the efficient transportation. So basically, the pre-10DL run on the edge device to determine the road condition captured and road condition transferred to the cloud. As I say, the SDN controller traffic condition from the cloud and develop flow rules. These flow rules are going to the SDN switches. Now, here is one point. Generally, you might be saying, other way thinking that GNS like signal. GNS means your navigational signals. So that is global navigational signals, which are used for the GPS and others, particularly that. But that is not used in their techniques. They are other way arguing that basically if you go for a GNS signal, it would be satellite connection and it should be of line of sight. Otherwise, the satellite link is not there, so you do not have the reliable data transmission. On the other hand, this approach is basically the ground-based approaches. So it's not of like that way the challenge of the satellite links and others. What is the GNS transportation systems or the location information here. So this augmented reality or virtual reality is incorporated in the handheld, these mobile devices having, the cars having the mobile devices. These mobile devices implement that, and that's make use of the efficient routing for the electric vehicle. Now, so this is another work where it is they have make use of the federated learning. As you may be knowing that the federated learning means there are local learning techniques which are having the parameter. These parameters are shared to the global controller. Global controller generates the aggregate those learnings and share it to the local controllers to update their data like that. So soft feed they have proposed. So this is again, this work is also from IIT Kharagpur Computer Science Group, Professor Sudhir Misra's research group. FL-based heterogeneous flow identification to prevent data privacy and security. So even that transportation has their privacy and security aspect to take care. So they have make use of this one, and they go for the federated learning for this, addressing the security and privacy issues in the transportation systems. Network slice selection that reduces the latency and packet routing. What I'm going to say here is that essentially this again tranquility issues needs a wireless connection, and which I'm going to say here is that RIS provides smart devices wirelessly. So this the challenging thing is that device has to communicate. Say the central exchange needs to talk to the mobile vehicle, IOV, if you can think of that, vehicles needs to talk with the central systems, or vehicle needs to communicate with another vehicle. But how this communication to be done? Where is this spectrum? Where is this channels? Or how this link reliable? So this can be taken care by using of this reconfigurable intelligence, which is a very, very important thing of the 6G or beyond 5G wireless communication. It's called intelligent reflecting surface or reconfigurable intelligence surface. Multiple dimensional array of metamaterials which are passive reflectors. If electromagnetic wave impinge, it just reflects. So it's basically a vector. It has reflection and it has phase. If you control the phase, so it's again a complex optimization problem. And classical complex optimization problem techniques solving is not effective. People in the literature of IRS-based research, they extensively use the deep reinforcement learning for optimization, solving this non-convex optimization problem for phase calculation, discrete phase calculation. Now, in recent one of our work, which is accepted a few days back in IEEE Globecom, what we have done over here, time critical analysis by electric vehicle using SDN IoT networks. So basically, again, same way that if the criticality aspects of the data or the transport vehicles are there, this to be processed in the edge, and this processed information to be passed to the SDN controller to be shared with cloud, and it will go to the SDA cache servers. So SDN controller run on the typical computationally expensive email, develop the policy. That policy is stored in the cache servers. So even if there is a communication failures in the SDN controller, this is a SDN cache server. Now you may ask this question that what we have there, because if you may, I'm talking about SDN IoT architecture previous and here also in this here the SDN IoT architecture, and here also what is new here is that what we have done here, we are making use of the DDQN, dual or double deep queue network. In standard DQ network, only one deep learning algorithm is used that basically select the action and estimate the Q value. But this creates a suboptimal solution. So in double deep queue networks or DDQN, there are two networks. One is the online, this is the main network. This selects the action, and there is another network which is target network. So the selected actions is used in the target network to calculate the or to estimate the Q value. So just listen, what I'm going to say is that double deep queue networks, they make use of the two networks. One is the online or main networks, and there is the second network, the target networks. So state selection, action selection and evaluation of Q value are done in the two different networks. That way the problems are isolated. So what is the problem of overestimation in DQN? That problem is solved in DDQN networks. So this is basically our contribution, which is, contribution in the sense we have intelligently make use of the DDQN approaches to address this suboptimal policies or overestimation of these policies, poor learning and other issues, or slow learning. That problem we are addressing by using DD2N. So, and of course, we are having a kind of complex optimization and constraint optimization problem for the transportation problem. If you can see, our objective function is the expected cumulative reward maximization, because we are having so many constraints. The constraints is, first constraint likes to means the valid path completions. That means the paths to be completed, whichever is the valid, that path to be completed. Critical path exclusion. Critical path exclusion means there are devices, the sensors or the cameras which capture some part is fire, in the some road segment there is fire or there are congestion. So based on that data, it needs exclusion. So we are having that critical path exclusions. We have energy constraints. That means we need to finish the communications before completion of the journey. Fulfillment of the capacity limit. We do not go for any overburden of any road segments. So each and every road segment should have to have certain load capacity to bear. And last one is the loop free. Any road segment should not be double traversed in one completion of the road. So we have make use of a constrained transportation problem where we have practicality aspects of the critical issues in the form of fire, in the form of exigencies, or in the form of your congestion is taken care, and we go for a policy and we make use of DDQN approaches for solution, which gives the benefits of reward value and energy consumptions is reduced and risks remain 0%. There were no no way there is a possibility of facing any kind of congestion or any kind of untoward incident in any road segments. Our policy take care of it. So smart, adaptive, energy efficient routing is proposed, and this is basically the continuation of this one. Now we are going for the another part, which is the industrial automation. Industrial automation, as you can, you know that robots are extensively used. Why robots? Not only robots are efficiently do the jobs than human being somewhat, but also which are dangerous for human being, robots are doing that kind. For example, application in welding, application in logistic transportation, applications in cleaning, even in the RF assignment, manufacturing, in all such cases. So robots are used for industrial automation, not only because of some of the tasks efficiently done by human being, robot than human being, but also which are dangerous or hazardous to the human. This is being taken care by the robots. Now these robots needs a kind of efficient lifetime, span of life. So every task completion, if you consider a cobot system, multi-robot cooperative systems, this should be moving in any industrial environment. So they need collision avoidance, they need navigation such that there should not be any kind of collisions, and it should have an energy efficient task completion, and of course within a specified time of life. Now waste collection challenges, as I say, focus on energy efficient multi-robot routing for waste collection in chemical industries to navigate avoiding collisions and energy efficient waste collections. Someone should not be, no zone should be uncovered or unserved because of the malfunctioning or because of the failure of any particular robot. So here, even if you see the existing literature, there are varieties form of the deep learning algorithms. Reinforcement learning algorithms, DQN, DDQN, even the partially observable Markov decision process are used in different forms. I will be talking about one more. I just like to share this because I assume that the audience are teachers. So how our normal day-to-day teaching help us to generate of life. I was taking a course on signals and systems, and there I had come across with a kind of functions which is ramp-like function only. You can see it is a sort of like functions. These functions are just going in and going on. We call it as an integrated dump type. If you go on integrating, then you dump like that. So one day in class, when I was talking about for my IT students, the student was not that way asking me directly the question. I insisted her to ask the question that you might be looking for what is the use of such functions in course curriculum when I'm teaching a course on signals and systems for students like IT. He took the questions and asked me, yes, I was just going to. You see, as I was talking about the things that human prediction and like that. So I take this example in a very lucid manner before going to the technical problem to take care. Imagine the behavior of a pattern can be like that. Imagine in a family, husband, wife, couples are there, and some way we mostly see like that. The women are working in some houses and others earn money, and eventually, I don't like to say like that way, the male persons are the drunkard or like that, so snatch the money and spend like that. So you can think of this behavior can be thought of like the women's, each and everyday work, and at the end it gets the total salary. The salary is taken by the particular person, and in 1 or 2 days just spend a whole, and it repeats every month and like that. So it can be a behavioral pattern of a particular human in the form of a periodic like. Then you see, then I take this is a lucid example. Then I take and give you an example. Imagine the way we, we work in our house. We have a dustbin, and per day, whatever the dust are collected, the dust are put to the dustbin go on increasing, and at one point of time, the dustbin full, the lid is closed, and next day we go to the, or in the same day we go and dump it to the, so the bins collected the dusts and all garbages, and the garbages are dumped to the places like that. And this goes on every day, periodically like that way. Now think of that, this to be done by automated way by some robots or somebody in an some machine to be done this job, collecting the garbage, put it to the bin, and once the bin is covered full, it will be. So it needs a kind of driving function. The function is like this. Now the question comes is there. Here is, if you see the activation function in the deep learning or in machine learning, we are using nonlinear activation function. There are different types of nonlinear functions like sigmoid, tan sigmoid, ReLU, RikiLeLU, like that. All these general characteristics of this activation function is what? This would be monotonically increasing. There should be some way non-linearity. There should be differentiability, like that. Now, eventual questions will come. Would this kind of function or a spiking neural network, imagine a kind of functions, a hard limiters, a kind of sigmoid, signum function. I don't know whether you know what signum function or not. You imagine a signum function is like that, a time function along the horizontal axis is time. From t0 to all, it is +1, and t0 to minus infinity, it takes -1. So it's a hard limiter. Any value from 0 to negatives all map to -1, and 0 to positive all maps to +1. It is also a negative function. And here is a jump discontinuity at 0. So it creates a problem of differentiability, but it's a negative function. Can such function be used as an activation function? Yes, it can be used as an activation function. The way human brain operates, the spiking neural networks, which I just asked my students to do this job, to take this problem of e-waste collections by means of robots and based on the spiking neural network. So spiking neural network for energy efficient neuromorphic computing in industrial dust cleaning robot. A brain-inspired neurocomputing approach for smart robot concept challenges application in one books we have published these papers. So it basically what is like to that, what is the, now we go back to the normal neural network and this spiking neural network. You see, in normal neural network architecture, we are having x1, x2, x3 inputs, and we go for w1, x1, w2, x2, w3, x3. Now, out of these x1, x2, x3, all x1, x2, x3 are not equally important, because if x1, x2, x3 are timely changing, so some of the time instant, one inputs are very significant, or some of the inputs are very significant and some are less significant, may not have any impact on the whole decision making process or like that, but still we are taking care of that using those all inputs, so it's not energy efficient. So can we look for a kind of things where a particular inputs may be effective at particular instant of time, the way human brain spikes or strikes. So this is the spiking neural network concept, and you can see here that a kind of approaches, when it triggers, it fires, it just creates some of these inputs are active in different time instance and make the systems energy efficient. So spiking time dependent plasticity learning rule is implemented, where reinforcement learning as it is used for the navigation or for the transportation of the robots. But the activation, dust collection or debris collections, and all these are activated by spiking neural networks, whereas the reinforcement learning is used for navigation and others, for path navigation. So this is one concept. In another work, what we have done, we have a multi-robot industrial automation, we have a continuous industrial environment, we are having a master-slave batches of multi-agent robots. We have one central robot, which is having the decision-making, central decision-making, and there are n-1 number of robots, they navigate. So this n-1 number of robots are equipped with the camera. The camera is always fed with very, visual data and all that. Based on this, there is a centralized system that based on, so each n-1 agents, slave agents, we call them. These slave agents run on a centralized policy, that proximal policy optimization to continuous control policy forever. So these agent slave robots are fed with camera, so it has the all visual information of the nearby slave agents, the master agents, the obstacle. With this, it just maintains the distance. So the master agents makes, the decision making tasks. So it just gives the high level decision making for all this, and the system is also taking care of it. So what is happening, that masters just monitors the load capacity of individual slaves. It goes to this, takes the the dust and put it to the dump. So it is in a centralized places there, and basically it is a hybrid deep reinforcement learning approaches is used for continuous e-waste collection in a continuous phase industrial environment. What is happening here, that if master agent gets failure or gets defective, then the system will take care of that. System will make a voting. There is a Q learning leaders election approaches. So out of this n- slave agents, based on certain reliability of the score and its proximity, where the central or the master agents get failure. So reliability of the n-1 slave agents and the proximity of the failed master agents. So it acts the role of a master agent and do the repairing. So it's basically the scalable, adaptive, and fault tolerant. Master agent operates as supervisory control and is responsible for high-level decision. So this is another works of industrial. There are lots of other way industrial manufacturing. So generally, I told basically in industrial automation problems at the beginning what I say: welding, manufacturing, logistics, dust cleaning, e-waste cleaning, whatever may be. These apparently look different types of job. But whenever multiple robots, cooperative robots or cobots are used for solving this one, it takes in the common framework of a energy efficient routing. All these diverse natures of problems, welding, manufacturing, logistics, transportation, cleaning, even they look different types of problems. But when involvement of the multiple robots and go for, cooperative operations, mostly the problem is mapping the framework of a optimal routing policy, energy efficient routing policy. So I like to address this old problem in a common framework, and that's basically we are looking for energy efficient dust cleaning or energy efficient task completion. By doing energy efficiency, like to means that how the given amount of energy will do the maximum or the good amount of job or good amount of task completion. So this is then industrial automation, industrial intelligent, industrial IoT, industrial Internet of Things relies on the massive connectivity. Here I am going to say how the communication, IoT, and machine learning, especially deep learning, the deep reinforcement learning, are extensively used in challenging wireless communication environment. I take two examples. I didn't use the many slides. I just put them in a single slide. You can see in the left part, there is a automobile industry. So the sensors are deployed, the sensors are collecting data, it is going to the central processing unit. It's a time critical data. The sensors are, this is central processing units monitor this manufacturing process, and it needs to take a critical decision. So sensors are supposed to monitor the manufacturing process and possibly influence the process by providing the feedback to the central processing unit, making the large factory fully automated. But in industrial environment, if you see, there are the metallic walls and others, there are sounds, there are noises and all these. This reliable data transmission from sensor to the central processing unit is always disrupted. If you go to the communication link, wireless communication link, there you will find that it should be attenuation, there should be electromagnetic wave scattering, there should be fading and all this, and there should be interfering effect or like that. So as it is a time critical again analysis, because you can see the sensor data to go to the central processing unit and it needs to process, it needs to time critical analysis, give it feedback to the sensor so that the manufacturing process will not be hampered or like that way. It's the essential things, how reliably this data to be transmitted to the central processing unit. And in particular, the complex industrial environment, the geometry are very different. How this reconfigurable, it's like to show that reconfigurable intelligent surface, because I'm talking about IoT in the framework of beyond 5G or 6G. So I need to take care of the communication aspect, and reconfigurable intelligent surface is used such that it can navigate the signal in the shortest possible path. So here is the shortest possible path is not the shortest possible path in the framework of Dijkstra's algorithms or Bell-Medford like that. Of course, if you consider this is a mesh type of network, that's true. But again, you have to consider the physical channel conditions, and you must be looking for a kind of map so that the network should, the signal to go to reach the central processing unit quickly, and from central processing unit to the sensor it comes to the board. This is one. Second is you can see the smartphones. Smart city, there is smart homes. So smart home means there should be smart devices from building to building, and these devices to communicate each other. Again, there is an issue of communication. So what it is expected that the smart homes to be equipped with in the wall or in the roof will be the reconfigurable intelligent surfaces. So it will be normal time, it will be used for smart home wireless connectivity, reliable wireless connectivity. But now the problems in the disaster times, when the buildings collapse. So how the search and rescue operation to be done, and that search and rescue operation to be done by robot, unmanned aerial vehicle, and etc. So they need a kind of data exchange in collaboration with the human. So humans are there, robots will be there, UAV there. They would have a very coordinated way of jobs. So even if these structures destroy, still when their normal communication gets lost, but this partially sustained, partially existence, this structure of reconfigurable intelligence surface can make use. So it is basically you can master slave based approaches. Some of these unaffected one take the role and it's take the role of masters, and other two include in the total systems, and that will improve the reliable communication. Because the what are the fragmented RIS parts are there, they may not be good enough for giving the reliable communication. So what one has to do, one of these has to take the lead of masters, and whatever the existing fragmented RIS need to include in the systems and go for a global structure such that reliable communication link can be done. So this is again where essentially the machine learning or the deep learning based approaches to be used for the effective decision making and learning. Needless to mention this education, and this is the last slide. I'm almost in the end of this talk. So personalized learning, basically, I think why I'm taking these slides. I'm not going to details talk about this, but so far I was moving. That basically it was the physical world space. It was the food, and I started my discussions with food and agriculture, then smart aquaculture, then healthcare supports in different way, weather and environment monitoring. Then we go for industrial transport and intelligent transport systems, smart vehicles, and all. We go for your, finally go to the industrial automation, etc. Now go to the human space, the learning, understanding of the human minds and all. So needless to mention, this generative AI or NextGen AI has an impact on personalized learning, language translation and voice assistance, AI-powered mobile learning. And what is more important, what particularly sometimes it starts me, that we need to have a huge. So what I like to say, that we should have an analytic mind, like the way generative AI, the human mind should have also an analytics ability, because we are having enough scope of data. I mean, we are having enough scope of facing different incidents, effects, and all. And this technology penetrates our mind space and makes a change or a shift in paradigms. So we have a kind of data which mind space will generate a kind of data, thought-provoking or thinking, which needs processing, which needs effectively utilized for welfare purposes only. So understanding of human mind, AI-driven data analytics. So we are having particularly the young generations, they are habituated to a kind of particular type of food or like that. So maybe we should go for a kind of prediction from the food habit, that what will be the expected outcome, should there be any kind of particular disease expected to appear or like that. So I think we should have go for like that. And obviously this problem space will be enriched and the solution pace to be also enriched, in the sense that there would be different members to be incorporated or augmented in the AI/ML DL. I just talk about simply the traditional methods along with basically the convolution neural network, variable autoencoder, like say generative adversarial network, deep learning approaches, reinforcement learning, and some version of the deep reinforcement learning and all. Of course, there are different problems, and of course there would be the other important terms like human language, the natural language processing, and LLM and others to be used extensively. Let us now future research direction, particularly the problems which I talk about, the healthcare. So for example, I talk about the remote healthcare problem, the physiological data and to be transmitted. I also like to enter inside the communication aspects by means of radio communication like that. Now it eventually happens sometimes the elder peoples or the surveillance purposes, the these sensors and others, people may not allow to use. So what would happen? Sometimes it may not be equipped with the sensor or devices or tracking of the human movement. These radio waves mapping, it's again a task of the AI-driven approaches. And this mapping and analysis, here is the scope of AI and generative AI. I think this is nothing new, that generation of pathological reports using generative AI is very, evolution-based approaches or transformer-based approaches or like LLM approaches or like industrial automation. Here I talk about the robot-based systems. Now imagine that industrial motors, which is rotating, it's monitoring. You need to have a domain adaptive knowledge transfer. Particularly, for example, when a robot, when a shaft rotate at a high speed, the torque, we never at the industry or rather at the factory, we never run our motors at high torque because the defect. So we do not have the sufficient data for testing in deep learning based approaches. We may not have, but we have one domain of data for safety or speed and other stock and others. So how this domain can be adaptive to the other machines, similar type of machines, that's again a challenge. So transfer learning based approaches, domain adaptive knowledge transfer, different but similar machines. This is one. Second thing is multimodal image super resolution. Say for example, RGB like of image giving a good type of resolutions and detail, space domain. So how we can go for a multimodal image super resolution? We might have a sensor of super resolution image providing one domain, very costly. Say for example, medical imaging. If you go for a MRI is very costly. And say for example, we have a low resolution image of the MRI, but we have a high resolution image of others, say for a USG or CT or something. So how can we create a high resolution image of MRI? Understand, we have a high resolution image of one medical imaging and low resolution image of costly, say for MRI. So how a guided structure of low cost high resolution image modality to be used with low cost image of particular domain, and how we can go to the high resolution of that desired domain. So that is a very challenging, and this can be domain adaptive knowledge transfer. Intelligent transport systems, I was talking about AI-based predictive maintenance. So how this can be predictive maintenance, how we can think about more efficient, the diverse types of type critical analysis, right? Anomaly detection in EV charging station. Safety in IoT, as I say, that Internet of Underground Things, the safety, health and environment trend. Particularly if you see that the mines are very, very, unhealthy, unsafe, because there are different gases are there. So we need to have a water level, or we need to have a humidity, temperature, and all these monitorings, continuous monitoring. We have location of the miners where they are working, its health monitoring, agronomy and all. So this data needs continuous analysis, huge amount of data, maybe in the nearby servers to be deployed at clouds, it needs analysis, and this decision making recommendation immediately go to that and go for the rescue operation. So safety, health monitoring, environment monitoring for the mines and the tunnels are very, very challenging, and here is scope of IOUGT along with the generative AI or reinforcement learning based approaches, or sort of machine learning or deep learning approaches. Agriculture, disease monitoring in plant and smart agriculture disease. People are already thinking of IoT based operation and like that. Building construction, as I say, that complex floor planning, multi-class walls, because if you see the images of the complex floor, it is basically nothing but a lines or curves. It is basically black and white image. There are not much edge because there is no change in like that way. So this analysis of complex flow to different people have different meaning. The customers or the clients have one meaning, and the builders and the engineers have the another meaning on that. So it needs analysis before construction. It needs what materials to be put where to make it the cost effective and others. So this is basically an and identify the different objects of a building construction. That's very, very important. And finally, when I was talking about, I didn't touch about any aspects of the security. Even there are some works I told that intelligent transport systems of IIT Kharagpur, they have making of the federated learning in software-defined network and IoT in the form of the security aspects. In everywhere when there is IoT and others, security is becoming a very, very challenge with different forms and different shapes and like that. So needless to make use of the blockchains and cryptographic techniques are there. So AIML IoT allows secure, intelligent, automated service specification application, and which is having a potential tremendous role in shaping the future society. So I think I end my talk. So if you have any questions, you can ask me.
Thank you so much, sir, for your informative session. I would like to ask all the participants if they have any doubt, you can ask to sir. I think, sir, no one is having any doubts.
It is only one way.
Sir, one simple question which might be silly, but many times you mentioned the abbreviation CS, like CS image reconstruction, and many other times I didn't. I do not know what the CS stands for, sir.
CS means compressive sensing or compressed sampling. Compressive sampling or compressed sensing. I told in the beginning, actually this is a techniques of signal processing. Basically, when you capture the digitize the image or other data, you need to follow Nyquist sampling theory. That means the highest frequency of the data that you go for digitize, it should have the sampling twice of that. But it is very time consuming. For example, MRI, when you do for MRI imaging, it takes 40 minutes or 50 minutes time. It's very time consuming. But it is possible to go for a compressive sensing. That means you take a subsample of the data acquisition, then you dump it to the machine, go for machine learning based or classical based approaches, generates a full resolution data. So what is basically mathematically, it is an underdetermined problem. You have an endpoint data by any means, but actual data is of endpoint. Somehow you have chance of getting endpoint data. Now your challenge from M, how you can go back to the N, that N to be closer to the original N. That's it, basically compressive sensing or compressive sampling.
Thank you, sir.
Thank you so much, sir, for clearing the doubt. Now I would like to ask other participants, if you have any doubt, you can ask with the sir. Sir is here with us only.
I would be happy if I would be happy if any comments or any other opinions are also there, because it would enrich me other way to define my idea or thinking other way. So please feel free to share your views and comments.
Sir, you also talked about, I didn't get that fully. You also talked about two approaches. One is like Fourier transformation based approaches, and another is this AI based. So if you sir, please.
Actually, your Fourier based approaches I talk about in the context of oral cancer detection, right? Generally, for oral cancer or any cancer, papillocular smear test is the standard test. That is basically time consuming. I mean, you need to go for a hazardous training process of your image. Data. And second thing is, PAP test is also having another problem, that radiologist subjective analysis depends on people to people value. So that's why these PAP strain images has limitation. In oral cancer, I think if I can go back to the slides, I think it could be clear. I like to say that we are taking multimodal pap smear images we are getting, as well as we are using Fourier transform, that interferometric, images. Basically the molecular signature is there. Infrared, Fourier transform infrared, spectrometer, spectroscopy. So it is basically having the bright field imaging. It is providing you the molecular signature, which can be an enhanced feature. So we are using PAP images, whatever attributes of PAP images are there, as well as the Fourier space, because actually any data, it has the original domain representation and you have Fourier transform domain representation. For your basic understanding, I say any data is nothing but a vector. A vector can be decomposed into component. So your original domain data is the original vector. And when you go for Fourier domain, as if you are decomposing your data into different components. Generally in vector decomposition, we have the horizontal component, vertical component, but in data, when it is a multi-dimensional vector, you are having a Fourier spectrum. So some of the information is clear in original domain, some of the information may not be clear in original domain, which can be available in the projection domain, frequency domain. So that's why two different domains are used for enriching our feature space. As I say that I didn't write here, I think yeah, molecular signatures which are there in FTIR. So this is used purposely in our backing based classifier approaches. We are again making use of the three classifiers, is VM, RF and MLP, and then it integrates, and we show that it gives a better results of accuracy.
Hello, am I audible, sir?
Yes, yes, yes.
Sir, I am Mohanandi Pal.
Yeah.
Sir,
yes, madam. Yeah, please.
Hi. Sir, you have told about the multi-resolution analysis, means 3x3, 5x5, 7x7, etc. So,
Right.
what is the benefit are we getting about while working with multi-resolution images instead of single resolution?
No, single resolution will give you one kind of details. The resolution is what? Resolution is discernible details of individual pixel. On information theory perspective, the amount of information conveyed by a single pixel is called resolution. Actually, two different views of the two different domain people about the resolution. The computer science people like that way. Electronics people other way like to say the amount of discernible details. I mean the amount of information conveyed by this. Now when you go for 3 cos 3, 5 cos 5, 7 cos 7, you just think of like you are closing your one eye and visualizing something. When you closing your one eye and visualizing something means you are localizing your view to a narrow space. So in machine perspective, you are having a DWT wavelet, you are having the multiple scale, but I didn't go to the multiple scale in wavelet. So for example, in wavelet, what happens if you have a 256 cos 256 first level, it gives 120, 120, then 64, 64 like that. We didn't go to the multi-resolution analysis of inherent DWT. Rather, what we have done there, we are using 3 cos 3, 5 cos 5, 7 cos 7. Possibly it was our work in, I think, your what I was skin cancer detection. It's a good question.
Yes.
A good question. I am coming to this point. It's an interesting thing.
Yes.
This one.
Yes, this
what
one.
happens?
This one.
It is not wavelet. We are not using wavelet here. Generally, if it is wavelet, we could do like that way. But equivalent wavelet, what the signal processing people do, now the computer science people who likes to avoid this complicated or complex signal processing, for them, it is a two-way. It is as good as like if you have an image, pass it to DWT, you are having low, low, high, 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 low, low, high. It is something like analogous that you are having a improved NS structure where there are 25 layers, convolution layers. One flank gives the, you can see the structure, you may not be visible to see, C convolution, batch normalization, ReLU, then pooling, then again unpooling. So what this unpooling likes to means what? You are giving back to the original size. You are increasing the size of the images. So first you are getting the details and then you are enhancing. So it is giving you the coarse version. As if one can do the DWT, the path A says it is the low version. Whereas the path B says that you do this one, you take 3 cos 3. So that means you are having a different net. the net size is, the hole size is different. So different materials are coming out of the hole. You are having a 3 cross 3 filter, means you are having a a small neighborhood. Then you are having a 5 cross 5, you are having a larger neighborhood. More elements are coming into the operation space. Then 7 cross 7. So you are going more blurring by doing 7 cos 7, 5 cos 5 compared to 3 cos 3. But again, you are including more number of neighboring features. So the longer connectivity or distance connectivity are coming into the pictures in the calculation. So what can,
sir,
yeah.
So sir, if we use, say, for example, if we use, say, 3 different resolutions, or instead of that, if we use, say, 7 different resolutions, so it is expected that the result will get better?
May, but at one point of time, you may not get, because if you see the human eye, you close, at one point of time you cannot get better further discernible data. So it should have it. And moreover, when you are having multiple size kernels and doing convolution, your computation processing is increased. You are enhancing you are increasing the feature space. You are enhancing the feature space at the cost of computation. I think some interfering signals are coming. Did I make it clear? I think you can go, but after a certain number of size, you may not get further detail, and which may not have any impact onto the classifier, because all these are going to the finally concatenation to the classifier. So classifier may not improve that much, even though you are using multiple size or larger size of kernel. And moreover, if you go multiple size, I mean the larger size, without considering the lower, you are basically doing more blurring. Say instead of using 3 cos 3, 5 cos 5, 7 cos 7, if you go directly 9 cos 9 or like that, you are considering more neighbors, means you are having more blurring. Right? You are having more blurring.
Sir, got that idea. Yes, sir. Thank you, sir. Thank you for explanation. Excellent talk.
Thank you so much, sir. Sir, a small query is there from my side.
Yes.
So as we can see, nowadays a lot of researchers are using synthetically generated data as a data set they are using. So sir, can you please tell how much reliable is this synthetically generated data?
See, if sometimes what cannot be cured must be endured. No. See, your machine learning or AI-based approach eventually demands the data. If there are sufficient data, you cannot learn. Your system cannot learn. But you are having a scarcity of data. So you have to go for synthetic analysis of data. Now, how you can do the synthesis data, that is a
Sir, sorry to interrupt.
Yeah.
Sir, can you please elaborate in the field of healthcare? If we are generating data synthetically in healthcare field, so how much beneficial is it for us as researchers?
See, then the question is, do you like to use the machine learning or deep learning in healthcare or not? Do you like to use or not?
Yes, sir. Sure.
If you like to use, you need to have enough domain data. You need, because your deep learning, machine learning based approaches. So either you have to go for transfer learning, one domain learning that you borrow and make use, or you have to go for creating large set of data. Now this synthetic data, as you are saying, there is an art. Total machine learning or deep learning, there is always an art. Now, if you are having a kind of images and generally the data generation or data augmentation, some affine transformation, rotation, translation, you will not get much diversity. Now, if you use a kind of, let's say even for autoencoder based approaches, if you use a variable autoencoder, it follows a probability distribution and your generated data comes from that distribution. So you may not get good, the diversity in the data. But if your domain data, if you have a back, tracking, if you say, for example, if you have a data, for example, creation, synthesis, data augmentation, if you just mask a part of your original data, understand, you mask a part of the original data and try to create that data. Then you remove the mask and compare your created data, how close to the original data. If your creation is good, What is the harm of the synthetic data? Now you see, the when generative adversarial network appears, it creates a paint or it creates an artistic work which defy the actual art. So if you generated data, now you can say it is medical, ethical, like it, okay. If you do not have that data, synthetic data, you do not have any solution, your patient will die, definitely. And now you are approaching, you are, of course, your synthetic data may not be that way reliable, but because of the scarcity of data, you cannot make use of, which is again essential, and you are using. You have to do that how synthetic to be meaningful, or in other sense, how the medical features to be written in the synthetic data. That's a challenge. If your medical data, synthetic data, retain the domain symptoms or domain information or features, I think it can be used. Why not? Even in the medical field.
Yes. Thank you so much, sir, for this elaborative answer.
Okay, thank you. If any other question or any points, it would be fine. Otherwise, thanks once again to the, I don't know whether anybody has any points or any comments.
I would like to request all the participants, they have any other doubt, you can share with sir. He is here with us only. So I think, sir, there are no more doubts left. Thank you so much, sir, for this very informative session. As we can see in the chat box, you have got a very good response from our audience that we have today. So thank you, sir, for this session.
Thank you so much. Thank you so much, organizer. Thanks for the nice introduction, and thanks Professor Padia and Professor Odhikari for inviting me this and delivering this lecture. Thanks the Department of AI/ML for.
Thank you, sir. On behalf of all of us, sir, I would like to present this token of appreciation as a small gesture of our gratitude for your valuable efforts and contribution. Please accept, sir, this small token.
Sure. It's my pleasure to accept this one. I accept this certificate of token of appreciation from your end. And thanks once again.
Certificate of keynote speaker, sir. This certificate is proudly presented to Professor Dr. Shanti Prasad Maiti in recognition of your outstanding contribution as a keynote speaker at FDP on recent research trends on NextGen AI, organized by the Department of CSE-AI and ML, Haldia Institute of Technology on September 16, 2025. Your expertise, sir, and dedication to the field have greatly enriched the experience of all the attendees and helped to make this event a successful event. So thank you so much, sir. Please accept this token of appreciation on our behalf. Thank you, sir.
Yeah, thank you so much.
Thank you for giving your time. Thank you, sir.
Thank you. It's my pleasure. Thank you all. Thank you, organizer. Thank you all participants for hearing and listening me. Thank you all. Bye.
Thank you, sir.
Thank you, sir.
So, thank you. So I'm making off. Yeah.
Yes, sir. Now, I would like to inform all the participants that the attendance link and the feedback link will be shared in the chat box and will be active till 5:50 p.m. today only. So please make sure that you fill the link correctly and with the same mail ID that you are using for the registration purpose only. So thank you everyone for joining with us today. Let's end today's session. Thank you all again for joining with us. Thank you.